Hello, everyone. Good morning. So can everyone see the screen, section 5.6?
Yes.
Okay, thank you. So this is the last section from this chapter, the binomial distribution. So we'll try to finish this section in today's class. So we are discussing about discrete random variable and its probability distribution. The binomial distribution, the binomial random variable, this is also discrete random variable. So the distribution for binomial random variable will be the binomial distribution, and which is also distribution for discrete random variables. Okay, so before going to the binomial distribution, first we need to discuss about some terms which we will be using in binomial distribution probability calculation. So the first term is factorials. So are you familiar with this term, factorial?
Yes.
Okay, that's great. Okay, so factorial means, so if we said 2 factorial, so that's mean we'll start multiplying from 2 and up to 1. So 2 times 1, this is 2. So k factorials means k times k minus 1 times k minus 2, and we'll multiply up to 1. And similarly, if we consider 3 factorial, so that's mean it will be 3 times 2 times 1, which is 6. And 4 factorial means we'll start from 4 and we'll multiply up to 1. Then it will be 3 times 4 is 12 times 2 is 24. And then 5 factorial is 5 times 4 times 3 times 2 times 1, and which is 1, 2, 0. The next term is binomial coefficients, and this is also called combination. So if you have idea about the permutation combination, then you should know this term. So this is n combination x, where n and x both are non-negative integers. So if n is positive integer, here n is positive integer, 1, 2, 3, 4, 5, 6, and x is non-negative integer. So x can take also 0. So x could be 0, 1, 2, 3, 4, 5, 6, yeah, and so on. So this coefficient, this is called n combination x. This is called the binomial coefficient. So this is equal n factorial divided by x factorial times n minus x factorial. Okay, so in the numerator we have n factorial, and in the denominator we have x factorial times n minus x factorial. So x is always smaller than n. So if let's consider x n5 and x is equal to, then it will be 5 factorial, and in the denominator x is here 2, so it will be 2 factorial, and n minus n is 5 and x is 2, so n minus x is 3 factorial, right? And okay, so let's consider n equal 4 and x equal 3. Then this means for combination 3, and which is equal 4 factorial over x is 3 factorial times 4 minus 3 factorial. So this is equal, the 4 factorial is, this is 4 factorial, and this is 3 factorial. 4 minus 3 is 1 factorial. So it will be then 4 times 3 times 2 times 1, and 3 factorial means 3 times 2 times 1, and 1 factorial is just 1. So now we can cancel out three, this two. So it will be just 4. But this is not possible actually. If we have like 3 and here 4, n is 3 and x is 4, this is not possible. We cannot have any combination like this. Actually, this means selecting 3 of them. How many ways we can select 3 of them from 4 items? So if we have total 4 items and x is 3, means we are selecting 3 items from 4 items. And how many ways we can select, we can make this combination, or we can select 3 items? That's actually 4 combination 3. Okay. Actually, we will be using these 2 terms in calculating the probability from binomial distribution or for binomial random variable. So we also need another term which is called Bernoulli trials. So what is Bernoulli trials? Trials means, for example, if we flip, if our experiment is flipping coin. So if we flip a coin once, this is 1 trial. This is called trial, 1 trial. If we flip a coin twice, then we have actually 2 trials. If we flip a coin 5 times, then we have total 5 trials. So each flip is called 1 trial. Okay. So what is Bernoulli trials? If the experiment has 2 possible outcomes, so the experiment should have only 2 possible outcomes, and denoted generically. So generally we denote it by S for success and F for failure. So we have 2 possible outcomes. We'll consider one outcome as success and the other one as failure. So for example, if we flip a coin, we'll have head or tail. So we can consider if we are interested to get a head, or if our concern is getting a head, then we'll consider this one as success. And we'll denote this one as S. And we'll consider T as failure. If we receive a tail, then this is failure. Or if our concern is tail, then we'll consider tail as success. Or if we are interested about getting tail, then we'll consider tail as success. Yeah. So the basic idea is we'll have 2 possible outcomes in the experiment, in each trial. Okay, number 2 is the trials are independent, meaning that the outcome on one trial in no way affects the outcome on other trials. Okay, for example, flipping a coin 3 times. So if you flip a coin first time, you might get either head or tail, right? In the second flip, you can also get head or tail. So the outcome in the second flip, it doesn't depend on the outcomes in the previous flip, right? So that's mean they are independent. The trials are independent. So this is the properties of Bernoulli trials. There should have only 2 outcomes, and the trials are independent. And third number is the probability of a success, called the success probability, and it is denoted by P, remains the same from trial to trial. Okay, so if we flip a fair coin, and if we want to get a head, if it is a fair coin, then probability of getting a head is half, right? So, and this is true for each trial. So that's meaning in the first flip, you have 50% chance that you might get H. And in the second trial, you have also 50% chance of getting H. And similarly, in the third trial, you have 50% chance of getting H. So that's mean the probability of success is same from trial to trial. It doesn't change. So this is the 3 conditions. If these 3 conditions are satisfied, then we say that the trials are Bernoulli trials. Okay, so here we have an example, outcomes and probabilities for observing whether each of three people is alive at age 65. So here you consider three people and each person is just one trial. So we have actually three trials here and there is two outcomes, either success or failure. Success means if the person is alive, then it is success. If the person is not alive, then it is failure. Because we are interested about whether the person is alive or not. So we consider three people. So that's mean total number of trials n is here 3. Okay, and the probability of success, that's mean probability that the person is alive at 65 is 0.8. So that's mean this is the probability of success. So what is the probability of failure? Total probability is 1. So there are only two outcomes. And you can also see that there are only two possible outcomes. Either the person is alive or the person is dead, right? So that's why we have only two possible outcomes. So the probability of success is 0.8. So probability of failure is 1 minus p, because total probability is 1. So that is 0.2. We also denote this probability, the failure probability, as q. So q is equals to here 0.2. So p is the probability of success and q is the probability of failure. Okay, so we have 8 possible outcomes here. And the first one is all three people are alive. So that's when the first one is alive and the second one and the third one. And they are mutually exclusive. So that's why we can just multiply these 3 probabilities to get the probability of 3 success. So the probability of 3 success is 0.8 times 0.8 times 0.8, which is 0.512. And similarly, first 2 persons are alive and third person is dead. So that's means 0.8, 0.8, and probability of F failure is 0.2, right? So that's why we multiply with 0.2, and this is 0.128. And here we have this first one is success, failure, success. So 0.8, 0.2, 0.8. So 0.128. And here success, failure, failure. So 0.8 times 0.2 times 0.2. And so on. So yeah, this is also Bernoulli trial, right? Because here we have only 2 possible outcomes and the trials are independent. Whether the first person is alive or dead, it doesn't depend on the second person, or whether the third person is alive or dead, it doesn't depend on the other 2 persons, right? Because they are independent. And here the probability of success is same from trial to trial. So that's mean the person is each person is alive at 65, the probability is 0.8, and this probability is same for each person. So that's mean the probability is same from trial to trial. Okay, so we can also construct this probability using tree diagram. Oh, okay, so why F is 0.8? Yeah. So what is F here? We have, I've already told that we have here only two possibilities. One is S, the other one is F. S means the person is alive and F means the person is dead, right? So the probability that the person is alive at age 65 is 0.8 and total probability is 1, right? So 1 minus 0.8 is 0.2. So the probability for F is 0.2. So that's why F is 0.2. Is that answer your question? Okay, thank you. You're welcome. Okay, tree diagram corresponding to the table 5.1 first. So the previous example, we can also calculate the probability using tree diagram. So we have actually 3 persons. That's mean we have 3 trials. So in the first trial, the first person might be alive or dead. So if the person is alive, then this is success. If the person is dead, that's mean this is failure. So we have only 2 possibilities. Now we'll consider let's consider first person is alive. So you already know this one. Now consider second person. So we have only also two possibilities, success or failure. So consider success is the outcome. So now consider the third person. It has also two outcomes, success or failure. And similarly for each one. So from here, if we have failure, then the third person has possibilities as S or F. And for the first person, if it is F, then for the second person, it could be S or F. And for the third person, it could be S or F. And for the third person here, it could be also S or F. So you can also calculate the probability using tree diagram. So 0.8 means this is S, so that's why 0.8. This is also S, that's why 0.8. This is also S, that's why 0.8. So you will multiply this 3 to get the probability of 3S. So which is this one. And if you go from here to here to here, then S, F, S. If you go here to here from here, then S, F, F. And if you go here, then there, then this point, then it will be F, S, S, F, S, F, 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 S, F, F, F. So you can by multiplying, you can calculate the probability. Okay. So for binomial distribution, we need Bernoulli trial and the number of outcomes containing a specified number of success. So that's mean we need also this coefficient n combination x. So in n Bernoulli trials, the number of trials is fixed, which is n. The number of outcome that contains exactly x success equals the binomial coefficient. So this is called binomial coefficient, and that's mean total number of trials is 1, and this is the number of success. So here x is the number of success we want. And n is the number of trials. For example, if we want to calculate the probability, if we flip a coin 5 times and we want to calculate the probability of getting head 3 times, that's mean we want to calculate here the number of success x equals to 3 and number of trials n is equals to 5. Okay, so this is the formula for binomial distribution. So let x denote the total number of success in n Bernoulli trials. So x is the random variable and which denotes the number of success from n trials. So the n could be 1, 2, 3, 4, and so on. But for each experiment, the n is fixed. For example, if we consider n here 10, then what are the possible values, possible number of success? So if x denotes the number of success from n trials, so what are the possible values of x in this case? Anyone? What are the possible values of x in this case? X is the random variable which denote the number of success from 10 trials. N is 10 here. So what are the possible values of x in this case? Anyone? Okay, so instead of writing this, you can just write like this 1, 2, 3, and if you think that this is up to 10, then you can say 10 like this. Okay, think about that. We have 10 number of trials. So what are the possible, n is the number of success from n trials, from 10 trials. So what are the possible values of x? So how many success you can have maximum? Maximum how many success you can have? Maximum number of trials is n. So the maximum number of success is 10, right? Yeah, 10 is the max. And what is the minimum? Yeah, if you get the minimum and max, then it is easy, right? Yeah. What is the minimum number of success? 1 or 0? Yes, this is 0. Because you might have all failure, right? So then the number of success is 0. So that's mean the x starts from 0 and end at 10. So that's mean x will be 0, 1, 2, and up to 10. And here you can say, so you can see x equals to 0, 1, 2, up to n, because total number of trials is n. Yeah. Okay, so the probability of getting exactly this small x denote a fixed number of success. Maybe this is x could be 0, 1, or 2, or up to n. So this is a fixed number. So this means probability of getting x number of success is equal n combination x times the power of p is x, and p is the probability of success, times 1 minus p to the power n minus x. So this is the this is the formula to calculate binomial probability. Or you can also write this one as n combination x, p to the power x, and q to the power x. Sorry, q to the power n minus x. So instead of writing 1 minus p, you can just write q. Q is 1 minus p actually. They are same. So the different notation, but same thing. Okay, so to find a binomial probability formula, the assumptions are, okay, so now the question is, how do we determine that this distribution follow a binomial distribution before calculating probability? So if the distribution doesn't follow a binomial distribution, and if you use the binomial formula to calculate the probability, that's not correct, right? The first thing is to determine whether the distribution of the random variable is binomial distribution or not, right? If x follows binomial distribution, then you can use binomial formula to calculate the probability. Okay, so what are the assumptions to determine the binomial probability? The assumptions are, first thing is n trials are to be performed. So that's mean the number of trials should be fixed. So n is the number of trials. So this is a fixed number. Number 2 is 2 outcomes. So there should have only 2 possibilities, not more than 2. If there are more than 2 possibilities or more than 2 outcomes, then it shouldn't be a binomial distribution. Then it will be something else. Yeah, but we are not going to cover that one. So number 2 is 2 outcomes, success or failure, are possible for each trial. Number 3 is the trials are independent. All the trials should be independent. The outcomes from one trial shouldn't depend on the outcomes of the other trials. So number 3 is determine n, the number of trials. Oh, sorry. Number 3 is the trials are independent, and number 4 is the success probability p remains same from trial to trial. So the success probability for each trial should be same. If you see this 4 assumptions, then you can use binomial distribution to calculate or binomial formula to calculate the probability. Okay, so now how to find the binomial probability? So these are the steps. First one is identify the success. So first you need to identify what is the success here, what we are interested about. Number 2 is determine p, the success probability. So then you have to determine the success probability. So what is the probability of success? Then the next thing is determine n, the number of trials. So what is the number of trials? You need to determine that one. Then number 4 is you need to use this formula to calculate the probability of success. Do you have any question? Okay. Thank you. Yeah, we'll go over some examples, then it will be like very clear to you. Okay, so here we have histogram for the binomial distributions, probability histograms for 3 different binomial distribution with parameter n is equal 6. So looking at the distribution, looking at the histogram, you will have the idea of the shape of the binomial distribution. So how the binomial distribution will look like. Okay, so if p is equals to 0.25, that's mean if the probability of success is low, that's means 0.25, right? And p is equals to 0.5, so that's mean the probability of success and probability of failure are same, 50-50 chance. And here the p is equals to 0.75, that's mean the probability of success has higher chance, right? So here p is equals to 0.25, probability of success is 0.25, and probability of failure q is equals to 0.75. And here q is equals to also 0.5, and here q is equal 0.25. That's mean we'll have actually more success here, right? Because the chance is higher for success, and we'll have 50 success and 50 failure. That's the expectation. And here we'll have actually if you consider n number of trials, so we will expect to have like 25% success and 75% failure, right? Okay, so now you can see this is the number of success. So we have total n is equals to 6 trials, so total 6 trials. So the maximum number of success we can have 6, right? So when p is equals to 0.25, then we expect to have less number of success, right? So that's why we can see that when success is 0, the density, the relative frequency or the probability is high, right? When x equals to 0, x equals to 1, x equals to 2, the probability is high, right? But when the number of success increases, the probability decreases, right? Because here the probability of success is 0.25. So we expect to have less number of success here, right? So that's why you can see that this is right skewed distribution, because the mean, the expected value or the expectation for are very close to the left. And here you can say we have 50%, 50-50 chance. So that's why we have higher probability at the middle, right? So that's mean the total number of failure and success are somewhat equal. We expect to have like same number of success and failures. So that's why this is symmetric distribution. And in this case, we have actually more frequency, or we have more probability for higher number of success. And you can see that for 4, 5, 6, we have higher probability. So this is left skewed distribution. So that's mean in binomial case, for binomial random variable, when p is close to 1 or p is greater than 0.5, then the probability distribution will be left skewed. If the p is 0.5, then this is symmetric distribution. If p is 0.25, then it will be right skewed distribution. And it makes sense, right? Do you have any question? Okay, thank you. Yeah, now we have these two formula to calculate the mean and the variance and standard deviation from binomial distribution. So if the random variables follow a binomial distribution, then the expected value of x, the random variable x, is equal mu is equal n times p. N times p. What is the expected value? Expected value is the average, right? The expected average. So that's mean the average of the population. So n is the number of trials and p is the probability of success. So n times p is the expected value. Okay, then sigma is equals to sigma square. The variance is equal n times probability of success times probability of failure. So n times p times 1 minus p. So this is the variance, and the standard deviation, sigma is equals to square root of variance. So square root of n times p times 1 minus p. So this is the standard deviation, and this is mean or expected value. So mu is, this is called mu, which is the expected value, and this is called sigma. This is actually a small sigma. This sigma is standard deviation, and sigma square is the variance. Okay, so now we'll go over some example. The first example is a fair coin is tossed 5 times. So we tossed a coin 5 times. What is the probability of obtaining 2 hits? Okay, first you need to determine the distribution of the random variable. So what do you think? Is it, I believe we will use them. Okay. Oh, so how do you figure out how many success or failures? Okay, so it will be given like how many success you want to have. Yeah. So for example, if you look at this example, so what is the probability of obtaining 2 hits? So we want to have 2 hits. So that's mean this is the number of success, right? Yeah, you're welcome. Okay, so first determine the distribution. So what do you think? Is it binomial distribution? Yeah, the answer should be yes, right? Definitely yes, because this section is about binomial distribution, right? Okay, the answer is yes, this is binomial distribution, but how do you determine? Can anyone explain? How do you determine this is a binomial distribution? Yes, that's a good point. There are only 2 possibilities. Yes, that's correct. Because we are flipping a coin, so we'll either have head or tail. Yeah, 2 possibilities. That's correct. Yeah. So we have how many conditions we have? We have 4 conditions, right? To be a binomial distribution. One is we have 2 possibilities. That's correct. Yeah. What are the next? Anyone? Yeah, fixed number of trials, right? So what is the number of trials here? 5. Yes, that's correct. Yes, 5. 5. That's correct. Okay, the next thing is the probability of success. What is the probability of success here? It is a fair coin, right? So what is the probability of success? 0.5. Yes, that's correct. So is it same from trial to trial? So we tossed 5 times. So is the probability same for each time? Yes or no? Yes, right? The probability is always same for, because this is fair coin. Yeah, it should be same. So that's mean we have all 4 conditions satisfied. The first one is there are only 2 possibilities. Then the number of trials is fixed, which is 5. Then the probability of success, which is p is equals to 0.5. And the probability of success are same from trial to trial, and trials are independent. That's also another condition. Trials should be independent. Here, the trials are independent. The outcomes for Each one trial doesn't depend on the outcomes from other trials, right? Yeah, they are independent. So that's mean this is definitely binomial distribution. Yeah. Not because we are this section is about binomial distribution, because it satisfied all four conditions. Yeah. Okay, so now we'll calculate the probability. So here actually they used k, but we'll be using x. So first calculate. So we have to find the probability of x is equal x, right? P to the power x 1 minus p to the power n minus x. Okay, so you already know n is 5 and p is 0.5. And what is the value of a small x here? Anyone? What is the value of x, a small x? The number of success we want to have, right? So how many success we want to have? We want to have 2 hits, right? So that's mean this is 2. So actually we want to find probability x is equal to. Yes, this is 2. That's correct. So we want to find probability x is equal to. So that's mean 5 combination 2 and p is 0.5. So 0.5 to the power x is 2 and 1 minus p, that's been 1 minus 0.5 to the power 5 minus 2. So this will be then 5 combination 2, 0.5 to the power 2 and 0.5 to the power 3. Now you can use calculator. So in your calculator, I think to find this one, you should use this one, NCR, or you can also see NR. You will see this symbol. Yeah. So you will be using this function, NCR, or this operator, or NR. On your calculator, you will see either this operator or this operator. So you will be using either this one or this one to find 5 combination 2. Okay. So, and finally the probability will be, after simplifying, it will be 5/16. And here you can see the calculation. So 5 combination 2 is 5 factorial divided by 2 factorial times 5 minus 2 factorials. And 5 factorial is 5, 4, 3, 2, 1. If you simplify this one, then it will be 10. So 10 times, and if you calculate this one, that will be actually 1/32. So if you multiply this to 10 times 1/32, then it will be 5/6. Yeah. So actually you do not need to show the details of the calculation. You can just use calculator. So you should learn how to use calculator to find the combination. Yeah. Okay, if fair coin is, the next example is, if fair coin is tossed 5 times, what is the probability of obtaining 2 hairs? Is the same thing, right? Yeah, obtaining 2 hairs. Yeah, it's the same example. So we're not going over this. So the next one is, a fair coin is tossed 7 times. So it is tossed 7 times. And what is the probability of obtaining 5 tails? Okay, so what is n here? And what is the probability of success? And what is success here actually? Which outcome we'll consider as success? Tail or head? What do you think? Tails, right? Yeah, because we are interested of obtaining tails. So that's why it should be tails. Yeah, the success should be yeah, getting a tail. So what is the number of trials here? And what is P? And what is x? Yeah, n is 7. That's correct. How about p? Yes, this is still 0.5 because this is a fair coin. And what is x here? X is 5. Yes. No, q is not 2 actually. Q is equals to 1 minus p, which is 0.5. Okay, thank you. So we want to find this probability. Then it will be 7 combination 5 and 0.5 to the power 5 and 1 minus 0.5, which is also 0.5 to the power 7 minus 5 is 2. Yeah. So this is the probability. And if you simplify this one, then after simplifying, it will be 21 over 128. Okay, next example is a fair coin is tossed 16 times. What is the mean number of heads? Okay, so let's find it. So let's do it by yourself. So a fair coin is tossed 16 times. So this is the number of tails. This is also binomial distribution, right? Yeah. So what is the mean number of heads? So this is 16 times. And this is a fair coin. So P is 0.5. We want to find the mean number of heads. Mean means expected value. We want to find expected value of X, or you can say mu. So what is the value of mu or expected value of X? So what is the value of mu? Anyone? Okay, I just got one answer, 8. How about others? Okay, 8. 8, 8, yes. Yes, that's correct. So this is 8. The mu is n times p, right? So the mu is n times p. So that's mean 16 times 0.5, which is 8. Yeah. Thank you. Okay, so the next example is a fair coin is tossed 16 times. What is the standard deviation for the number of heads? Okay, let's find this one. So n is 16, p is 0.5, and 1 minus p is also 0.5, or you can say q is also 0.5. So find the standard deviation, find sigma. So what is the value of sigma? Also find the variance. What is the value of sigma square and sigma? So this is variance, and this is standard deviation. Okay, so what is the value of sigma and what is the value of sigma square? Yeah, find it and let me know. Why is it so why is it 9? I'm sorry, I didn't get you. Oh, this is not 9. I'm sorry, this is actually question mark. Yeah, I'm sorry. Yeah, you have to find sigma square, and yeah, this is not 9. Yeah, this is not actually 9. This is question mark. Yeah, my writing is, even I cannot, sometimes I cannot understand my writing. Okay, so you found 2. Let me check. Mhm. Yes, the standard deviation is 2. Sigma is 2. Yeah. So sigma is 2. So sigma squared will be then 4, right? So how do you calculate this one? We know sigma squared is equal n times p times 1 minus p. So that's mean 16 times 0.5 times 0.5. So which is 4. So that's why the sigma square is 2. Yeah, thank you. Okay, the next example is a company makes electronic components for TVs. 95% pass the final inspection and 5% fail. So, and they need to be fixed. So 120 components are inspected in one day. So how many components inspected? 120 components inspected. So what is the expected number that fail in one day? So what is the, what do you think? Is it binomial distribution? Yeah, definitely this is a binomial distribution because this is section 5.6. Yeah, okay, I'm just kidding. Okay. So this is binomial distribution because what is the number of trials? And what is the value of P? And what is the value of Q or 1 minus P? And we what is the expected? We want to find the expected, and what is the value of mu? Okay, find all of this. So find the value of n, and find the value of P, and find the value of Q, and find mu. Yeah, find all the values and let me know. Yeah, I'm thinking to give you some extra credit from next class for your response. So if you get, whether you get correct answer or not, it doesn't matter. So as long as you respond, I should try to give you some extra credit. Okay, I'll figure out how to give you extra credit for that, for your response. Yeah, maybe I will save all of your response, and at the end of the semester, I will check and give you some extra credit based on your response. Okay, find all the values. Find n, p, q, and mu. Yeah, n is equals to 120. Thank you. Now, what is the value of p? Yeah, n 120, p 0.5, p 0.95, 0.5, 0.5, 0.5, 0.5, okay, 0.05, okay. Yeah, I think who are answering 0.5, they are doing little mistake. 5% is not 0.5, 5% is 0.05. Yeah, I am assuming that you wanted to write 0.05, not 0.5. Yeah. Okay, but what is value of q? Q is 0.95. Okay. Okay. Yeah. 0.95, 0.95, q is 0.95. Yeah, that's correct answer. Q is 0.95. Yeah, here actually the important thing is you should be very careful. When p is 0.5, then it's fine. Even if you do mistake, you will get the correct answer. You do mistake means you do mistake to calculate P and Q correctly. If you fail to calculate it correctly when P is 0.5, you will get the correct answer, because here there is no chance that you will do mistake, because this is a 0.5, this is also 0.5. But if P is a smaller or greater than different from 0.5, then there is a chance that you will do mistake. Yeah, the most important thing is to determine the success. So yeah, that's the most actually important thing to determine. So here, what is the expected number that fail in one day? Here we are interested about the fail, right? So how many components fail? Sorry, how many components failed the inspection, right? That's we are interested about. So here the success is the fail. Success is not the pass, right? Yeah, some of you might think that, okay, so this is pass, 95% passed. So you might think that, oh, the pass, that's mean this is success. This is not the success here, right? So in case of binomial distribution, the success is what we are interested about. Here we are interested about the fail, right? Number of fail. So that's why the success is 5%. And so the probability for success is 0.05. And probability for failure is 0.95. Q is equals to 0.95. Right? And N is 120. So what is the expected number that fail in one day? So the expected number means we want to find the expected value of X, which is N times P. So that's mean 120 times 0.05. So this is the expected value in this case. And the expected value is here 6. Yeah, that's correct. This is 6. Yeah, thank you. This is 6. Yeah. So let's go to the next example. What is the number that passed what is the variance? Okay, so all the informations are same. That's mean N is 120, P is 0.05, and Q is 0.95. So we have to find the variance. We know that sigma square is equals to N times P times Q. Or you can say N times P times 1 minus P. They are same actually, because Q is 1 minus P. Or you can also write this. Yeah, both of them are same. So that's mean 120 times 0.05 times 0.95, which is equal which is equal 5.7. This is equal 5.7. Yeah, the correct answer is 5.7. Yeah, that's correct. Yeah, so you got the correct answer. Thank you. Okay, so the next example is a fair cubical die is thrown 4 times. So a die is thrown 4 times. So since this is cubical, so that means it has 6 sides. So use the binomial probability formula to calculate the probability of exactly 2 5s. Okay, so this problem is a little confusing. Okay, a fair cubical die is thrown 4 times. So what is the number of trials here? Use the binomial probability formula to calculate the probability of exactly 2 5s. So we are interested about 5s, right? Only one outcome. Okay, so the first question is it a binomial distribution? If the answer is yes, why it is binomial distribution? Yeah, if you understand this problem, then I think you can solve, you will be able to solve most of the problems related to binomial distribution if you understand this one. Yeah, that's correct answer, because it's either 5 or any other outcomes, right? Yes, 2 possible outcomes. But some of you might think that it has 6 possible outcomes, right? You might get 1, 2, 3, 4, 5, 6. But it has 2 possible outcomes. Why? Because either you will, we are interested about 5. So we have only 2 options, either 5 or not 5, right? So 5 is one outcome, and the other outcomes are 1, 2, 3, 4, 6. So they are together one outcome, and this is one outcome. So we have only 2 possibilities, either 5 or not 5, right? Yeah, that's correct. So you got it. Yeah, thank you. Okay. So what is the probability of success? Yeah, now find the probability of success and probability of failure. Yeah, what is P and what is Q here? And what is X? Yeah, write all the answers together. The value of N, P, Q, X. So what is the value of N? What is the value of P? What is the value of Q? And what is the value of X? Okay, so instead of just writing the number, you can respond like this: N equal the value of N, then comma, then P equal the value of P, then comma, Q equal the value of Q, then comma, and X equal the value of Q. So you can, yeah, you can submit your answer like this: N, P, Q, X. N equal 4, P equal 0.25, Q equal 0.75, and X equal 2. Yeah, so I just received one answer. N equals to 4, X equals to 5, X equals to 5. No, we want to get exactly 2 5s. Here 5 is not the outcome. So yeah, 5 is outcomes, but how many 5s do we want to get? We want to get 2 5s. So that's mean we want to have 2 successes. Yeah, X should be 2. Yeah, many of you responding 0.25 and 0.75. Okay. 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 For, yeah, most of you are getting N and X correctly, but P and Q are not correct. They are incorrect.
So is P the probability you get it correct?
Yeah, the P is the probability of success. Probability of success means probability of getting a 5.
And the 5 one time, or it's 5 2 times?
So yeah, for each trial, 2 times actually, this one actually comes later when you will be calculating the probability.
Oh, okay. So it's 4, then 1 6, 5 6, then 2.
So that's me actually in each trial. So when you will be calculating the probability of success, that's good question actually. When you will be calculating the probability of success, you will consider just one trial, not more than one trial. The probability in one trial. So think about that. If you just roll a die once, so what is the probability of getting 5? 1/6, right? Can you hear me? And what is the probability of not getting 5? 5/6, right? Because we have total 5 outcomes here. Yeah. So the probability of success is 1/6 and probability of failure is 5/6, right? So does that answer your question? Yeah, now you got the correct answer. 1/6, P is 1/6, and Q is 5/6, and N is here 4, and X is 2. Yeah. Okay. Thank you. Yeah, now we have to find the probability of getting exactly to 5. So that's mean X is equal to. So probability of getting 2 success. Yeah. So the next problem is, this is also similar type of problem. Here actually we have 5 sides. So this is a spinner. So a spinner has 5 sides. So it has 1, 2, 3, 4, 5. And each time the spinner is spun until it lands on one of the 5 edges of the pentagon, the spinner is spun 4 times. So it is spun 4 times. So that's mean n is equals to 4. Use the binomial probability formula to calculate the probability of exactly 2 ones. So here we are interested about the outcome 1. So that's mean the probability of success P is equals to 1/5 and Q is 4/5. And exactly 2 ones. So that's mean we want to find the probability X is equal to. So we want to find this probability. So that's mean this is 4, 2, and 1/5 power X, which is 2, and 4/5 power n minus X, so which is also 2. 4 minus 2 is 2. Yeah, so this is the probability. So if you simplify this one, then it will be 96/625. So if you simplify this one, then it will be 96/625. So you can also get your answer in decimal points. That's also fine. Okay, the next problem is a fair coin is tossed 5 times. So a coin is tossed 5 times. So that's mean n is equal 5. We have to use the binomial formula to calculate the probability of at least 4 hits. Okay. So here n is 5. P is 0.5. This is a fair coin. Q is also 0.5. So we want to find the probability X is at least 4. So we want to get minimum 4 success. So that's mean we want to find the probability where X is either 4 or greater than 4. So that's mean X greater than equal 4. So we want to find this probability. So this means probability of X is equal 4 plus X is equal 5. So that's mean you have to find all the probabilities where X is 4 or greater than 4, and then you will add them together. So we want to find this probability. So probability 4 is 5 combination 4 and 0.5 to the power 4, 0.5 to the power 1 plus 5 combination 5. X equals to 5 is 0.5 to the power 5 and 0.5 to the power 0. So this is the probability. So if you simplify this one, then it will be 3/16. So if you simplify this one, then it will be 3/16. You can use calculator to simplify this one. Okay, the next problem is a fair coin is tossed 6 times. So n is equals to 6 here. Find the probability formula to calculate the probability of at most 2 tails. So we want to have maximum 2 tails. So maximum 2 success. So P is equals to 0.5 and Q is also 0.5. And we want to find the probability X can be at most 2. So that's mean X equals to 0 plus probability of X is equal 1 plus probability X is equal 2. So if you plug in all the numbers and if you simplify this one, then after simplifying this, the answer will be 11/32. The answer will be 11/32. Okay, fair cubical die is thrown 4 times. So here n is equals to 4 and calculate the probability of at least 2 threes. So here P is equals to 1/6 because we are interested about threes. So that's mean this is 1/6 and Q is 5/6. And we want to find the probability at least 2. So that's mean X less than equal 2. So that's mean we want to find X is equal 0 plus probability of X is equal 1 plus probability of X is equal 2. So this will be then the answer for this one will be 19/144. So this is the correct answer. So do you have any question? So is it clear how to determine the binomial distribution and how to calculate the probability from the binomial distribution? Actually, I am showing you many problems in the class so that you can understand each concept clearly. If I just go over 1 or 2 examples, then yeah, you will get some idea, but you will not have clear idea about the concepts. So that's why I'm going over like too many problems. So do you have any question? Okay, so today is Thursday. So next week I'm planning to give you one more quiz. And maybe I might give you one Tuesday or Thursday. Yeah, and I'll give you the quiz during the class time. And this quiz will cover chapter. So first one covers chapter 1 and 2. So this quiz will cover chapter 3 and 5. Yeah. So you'll have maybe 2-3 questions from chapter 3 and 2-3 questions from chapter 5. So I might give you the quiz either on Thursday or Tuesday. So your first test is on October 7th, I guess. So it is on the syllabus, you can check. And your first test will cover chapter 1, 2. Okay, I will discuss about it later. And I'll give you the review problems for test 1 at least 1 week before the test, so that you get enough time to go over the review problems before the test. Okay, the quiz is, I think, 10%. So if you miss one quiz, then yeah. So maybe you will lose 3 to 4% of the total grade. Do you have any other question?